Morning friends, we discussed about the application of the PN junction diode as a photo detector and also the light emitting diode. Today we are going to discuss about the important application of PN junction diode as a solar cell. Right? What is the construction, working and the usage of the solar cell and from which material the solar cells are fabricated. For that purpose, the solar cell is also a PN junction diode. But here, yes, the light is incident on the PN junction. The EMF is generated in depletion region or the junction of diode. Right? Okay. Now the question is that explain the construction, working and use of the solar cell. Solar cell is basically a PN junction which generates the EMF when the solar radiation falls on the PN junction. When the solar light is incident on the PN junction, so PN junction diode produce the EMF. That is the basic concept of solar cell. Sunlight is not always required for solar cell, but the energy of the photon of the light, which is greater than the band gap energy Eg of a semiconductor, can also produce the EMF. So we believe that in solar cell, the sunlight is required always. No, there is no reason. The sunlight is not always required for solar cell. But the energy of the photon of the light, which is greater than the band gap energy of a semiconductor, can also produce the EMF or the photovoltaic. So solar cell is the PN junction. When the sunlight is incident on the junction, so PN junction diode produce the EMF. It is not necessary always the sunlight is required, but the energy of the photon of a light must be greater than the energy, band gap energy of a used semiconductor. It also produces the photovoltaic. The principle of the working of photodiode and solar cell are same, and it works on the principle of the photovoltaic effect, but it not require the external battery in solar cell. Now the principle of the working of the photodiode and solar cell are same. In both cases, the sunlight incident on the PN junction diode. But in photodiode, the reverse bias is required to produce the current. While in solar cell, here no any bias is required, or no any external battery is required in solar cell. There is the main benefit of the solar cell over the photodiode. The principle of the working of the photodiode and solar cell are same, and it works on the principle of the photovoltaic effect. Photovoltaic effect, that means as the sunlight is incident, what are the electrons in covalent bonds absorb the energy. When the energy is more than the band gap energy, cross the junction and produce the current. But in solar cell, no any external battery is required. So just we studied about that. In photodiode, the reverse bias is required, while in light emitting diode LED, the forward bias is required, while in solar cell, no any bias is required, no external battery is required, because this PN junction acts as a self-battery. It produces the current. Okay. The solar cell and its cross section is shown in the figure. Here solar cell and its cross section. Here two layers, one layer of N-type semiconductor over the P-type semiconductor. The layer of N semiconductor is very thin, and above the N-type semiconductor, a metallic grade or the metallic finger electrode are placed. So there is actually one electrode, and the base of this, that means the P-type semiconductor, is also connected with the metallic plate. There is work as a back contact, and there is the top contact. Solar cell is connected with the bottom and this metallic finger electrode. So that is shown like this. N-type semiconductor, P-type semiconductor, there is the base, there is the back contact. Here, this dot represents the metallic finger electrode or the metallic grid. Now in the construction, a P silicon wafer about 300 micron is taken over which a thin layer of 0.3 micrometer of N silicon is grown on one side of diffusion process. P-type semiconductor with this thickness 300 micrometer. Over this P-type semiconductor, the thin layer of N-type silicon semiconductor having the thickness is 0.3 micrometer. So as a result, whatever the light is incident on the top surface of this cell reaches to the junction due to the thin layer of N-type semiconductor. The other side of the P silicon is coated with the metal on the other side of the P semiconductor is coated with the metal, that means for back contact. And the top of N silicon layer, top of this N silicon layer, metallic finger electrode is deposited. This acts as a third contact. The back side of the P-type semiconductor is metallic coated for the connection, while the top of the N-type silicon layer, a metal finger electrode, that means the metallic grid is placed. That is for third contact. The metallic grid occupies only a very small area, very small fraction of the cell area, approximate 0.15, less than 0.15, so that the light can be incident on the cell from the top. Here, the third contact is in form of a metallic grid with a finger shape. So as a result, what's happened? A very small fraction of the cell area, less than 15%, is occupied by this metallic contact, so that light can be incident on the cell from the top. And due to that result, this type of the finger metallic electrode are placed on the top of the solar cell. So within this gap, the light can enter on the N silicon and reaches to the PN junction. Right? How the EMF produced, we discussed just before it. First we revise it. What is that? The solar cell is basically a PN junction which generates the EMF when the solar radiation falls on the PN junction. Sunlight is not required always for the solar cell, but the energy of the photon of the light, which is greater than the band gap energy of a semiconductor, is also produced the photovoltaic. For each and every time the sunlight is not required in solar cell, but whatever the light is incident on a solar cell should have the energy greater than the band gap energy of a used semiconductor. It also produces the photovoltaic. The principle of the working of photodiode and solar cell are same, and it works on the principle of photovoltaic effect. But it is not required the external battery in solar cell. While the photodiode requires the reverse bias mode, while the solar cell not require the any bias. Okay. Now the cross section of a solar cell and figure is shown in the diagram. A P silicon wafer about 300 micrometer is taken over which a thin layer of N silicon, approximately the 0.3 micrometer, grown on one side of diffusion process. The layer of the P silicon semiconductor having the thickness is 300 micrometer. Over this, a thin layer of N silicon semiconductor having the thickness is approximately 0.3 micrometer is done on P-type semiconductor. As a result, the light incident on the top of N side of a semiconductor can reach to the junction. Okay. The other side of the P, that is the base of this solar cell, is coated with the metal. On the top of the N silicon layer, a metal finger electrode is deposited. This acts as a front contact. The back side of the P layer is metallic coated for the connection, while the top of this cell, here the metallic finger electrode, that means the metallic grid is placed, that is for the front contact. The metallic grid occupies only a very small fraction of the cell area, less than 15%. This metallic grid only occupies less than 15% cell area of the surface, so that the light can be incident on the cell from the top. The EMF produced in a solar cell when the light falls on it due to the three basic processes. How the EMF produced in a solar cell? So that is divided into the three basic processes. One is the generation of the electron hole pairs due to light with HF greater than EC close to the junction. Already we discussed these three basic concepts in photodiode. What's happened when the light is incident on the junction? So electron hole pairs are generated. These electron hole pair are generated when the light with HF, that means the energy of the incident light must be greater than the band gap energy. At that time, the electron hole pair are formed near the junction due to the broken of the covalent bond. The separation of the holes and electrons due to electric field of the depletion region, electrons are swept to inside and holes swept to the p side. In depletion region, the electric field already exists in the direction from N to P. As the electron hole pairs are formed, so due to the electric field of the depletion region, before this electron hole recombine, this electron hole pair are separated and electron swept towards the inside and holes to the p side. Clear this? Okay. Now the electrons sitting in the inside are collected by the front contact. What are the electrons are sitting in inside? Are collected by the front contact. And what are the holes are moving towards the p side are collected by the back contact. Thus, the p side becomes the positive and n side becomes the negative, giving the rise to the photovoltaic. Thus, the p becomes the positive and this front becomes the negative. So, the potential difference arises between the back and front contact. Again, how the EMF produced in a solar cell? When the light having the energy HF is greater than the EZ, produce the electron hole pair in the junction. Right? The separation of the holes and electrons due to the electric field in depletion region, the electrons are swept towards the inside and holes are swept towards the p side. The electron reaching in the inside are collected by the front contact, and what are the holes reaching in p side are collected by the back contact. Therefore, back contact becomes the positive and front contact becomes the negative. As a result, the photovoltaic arises between back and front contact. So that is the basic information about the solar cell. So how that is connected in the circuit, what are the characteristics we discuss. Now what's happened when the solar cell is connected with the external resistance, that means the load. Just we discuss how the EMF produced in a solar cell. As the light having the energy HF is greater than the band gap energy is incident. So electron hole pair are generated near the junction. So electric field in the depletion region in such a way that electron holes are again recombined before it separate the electron and hole due to the electric field in depletion region. So as a result, the electron swept towards the inside and hole swept towards the p side. So the electron reaching in N region are collected by the top contact, and what are the hole moving towards the p side are collected by the gate contact. Thus the EMF is generated between the top and bottom contact. When the top and bottom contact are connected by the load resistance R, so photocurrent IL is flowing in the circuit or through the cell is shown in the figure. So when an external load is connected as shown in the figure, a photocurrent IL flows through the load due to incident of light on a solar cell. That means the electric current is generated in PN junction down as the light is incident on a solar cell. So here there is the PN junction down, there is the P-type semiconductor, there is the N-type semiconductor. As the light incident on the junction, the electron hole pair are formed, electron swept towards the N and hole swept towards the P side. Electron collected by this third contact, that is the negative, and that is the back contact. So hole collected by the back contact, it becomes the positive. When the load resistance is connected between these two contacts, so current are flowing from P to N. The IV characteristic of solar cell is given in fourth quadrant, because the solar cell does not give the any current, but it supplies the same to the load. Again, the IV characteristic of solar cell is given in fourth quadrant of coordinate axis, because the solar cell cannot do any current, but it supplies the current to the load. Yeah. So that is the working of solar cell, how the current is flowing or the generate in the solar cell due to the incident of light. Clear? Now what are the uses of solar cell? Uses of solar cell or the application of the solar cell are to power electronic devices in satellite and space vehicle. What are the satellite? The electrical energy is required for this type of the satellite and space vehicle. To produce the energy, the solar cell or the solar panel are used. That means the two power electronic devices in satellite and space vehicle. Second is as a power supply in calculator, electronic watch and camera, etc. For the power supply in calculator, at present we are using the solar panel in calculator, also in watches and also in camera. Many solar cells have a series with a parallel connection that can be provide the required voltage with the current. Such connection is known as the solar panel. Again, what are the uses of the solar cell? To power electronics devices in satellite and space vehicle. To provide the power in satellite and space vehicle, the solar cells are used. Now, is a power supply in calculator, camera and also the watches. Now, the many solar cells have a series or parallel connection that can provide the required voltage and current. Such a solar connection is known as the solar panel, and this type of the solar panel at present we are using in our house to produce the necessary electricity. And also in past and also at present, this type of the solar panel are also used in the satellite. So as a result, the required voltage and required current we can obtain from this series with the parallel connection of solar cell. Right? Okay. So these are the applications. Now, material for fabrication of a solar cell. Which material is required to fabricate the solar cell? So semiconductor with the band gap close to 1.5 electron volt are ideal material for solar cell fabrication. Not from all the semiconductor we can prepare the solar cell, but the semiconductor with the band gap energy very close to the 1.5 electron are ideal material for solar cell fabrication. So these materials are silicon having the band gap energy is 1.1 electron volt. Gallium arsenide having the band gap energy is 1.43 electron volt. Cadmium tellurium band gap energy is 1.43 electron volt. And copper, indium, selenium 2 having the band gap energy is 1.04 electron volt. Etc. Semiconductors are used for the fabrication of solar cell. Again, which material are used for the fabrication of solar cell? The semiconductor with the band gap close to 1.5 electron volt are ideal material for solar cell fabrication. These materials are silicon, band gap energy 1.1 electron volt, gallium arsenide, band gap energy 1.43 electron volt, cadmium tellurium, band gap energy 1.45 electron volt. Next, copper, indium, selenium 2, having the band gap energy is 1.04 electron volt. Etc. semiconductor are used for fabrication of solar cell. Now, the following are important criteria for selecting the right material for fabrication of solar cell. What is the criteria for selecting the material for the fabrication of solar cell? First is the band gap is about 1 electron volt to 1.8 electron volt. Whatever the material is selected, this material should have the band gap energy is in order of or the lies between 1 electron volt to 1.8 electron volt. Second is high optical absorption about 10⁻⁴ per centimeter. That means whatever the material we are used, this material should have the high absorption capacity. So whatever the light is incident on it, without reflection, all the light is absorbed. So this absorption is about 10⁻⁴ per centimeter. Next is high electric conductivity. That means the resistivity is less, so this material must be high electric conductivity. Next is the raw material should be easily available. This material also easily available is good. And third is, next is the cost should be lower. The cost of this type of the material must be less. So there is the criteria to select the ideal material for fabrication of solar cell. Clear this? Okay. So just we discuss about the application of the PN junction diode about like as the photodetector, photodiode. Second is the LED. Next is the solar cell. Right. So these three widely used application of the PN junction diode. Now after that we are going to start our discussion about the logic circuit and logic